In this three-part series, I'll take you step by step through the process of building a blog platform using Spring Boot and Spring Security. And this is part one, in which we'll cover analyzing the project brief, designing the implementation, setting up the project, and creating the JPA entities, with part two focusing on security and part three wrapping up security and managing blog posts. This project sits partway between beginner and intermediate and would be approachable for beginners as your second or third project. Otherwise, check out the task tracking app builder. There'll be a link up here as your first project. That said, this project is special because we'll be using JWTs with Spring Security, we'll be using Project Lombok, and we'll be using Mapstruct as well. You'll find the lesson write-ups and the project source code, including the source code for the React frontend on the Devtiro community site. And you can join for free. There is a link in the description below. If you're new here, welcome. My name's Aaron. I'm a developer with over 15 years of experience, and I'm here to help you learn Java, Spring Boot, and all those related tools. So with all that covered, let's get started. In the upcoming lessons, we'll be focused on building an application rather than discussing the theory in detail. So a foundational knowledge will help you to get the very most out of this project. To follow along and build the blog platform app, you'll need a practical knowledge of Java, Maven, Docker, and PostgreSQL. By working knowledge, I mean that I won't be explaining how these technologies work in our project. I'll assume that you're already comfortable with them so we can focus on building our application. If you're not so sure, I'll leave some resources in the description below which will help you get up to speed. Now for Spring Boot, you should already be comfortable with the basic concepts. If you've taken a beginner's course on Spring Boot, then you should be set. Now, where this project becomes a little more challenging is that we're going to be using Spring Security and JSON Web Tokens, otherwise known as JWTs. So a basic knowledge of Spring Security and how JWTs work would be very beneficial. Although it won't be strictly needed, as once our security is configured, we'll not need to revisit it. Now, a special note on our project's React frontend. Of course, this project is focused on building a Spring Boot application. However, I do offer the same React frontend that I use for you to download. We'll be using the Node Package Manager, or NPM, to install the dependencies that we need for the frontend. So although you don't need to know how Node works or how to build a React application, it would be very beneficial to know what Node is and what it means to use NPM. Otherwise, a quick read of the Node website should be enough to understand this. So with that covered then, in the next lesson, we'll look to set up our development environment. So let's set up our development environment. To build the blog application, you're going to need the Java Development Kit, or JDK, version 21 or later. You can check the Java version by opening up a terminal or a command prompt and typing java-version. You can see here I'm running version 21.0.5. If you see an earlier version, then I'd recommend heading over to oracle.com to download JDK 21 or later. Or if you prefer an open source JDK, then you can download it from Adoptium, which is part of the Eclipse Foundation. As long as it's version 21 or later, either JDK should work fine for this project. We'll be using Apache Maven to manage our project, although you'll not need to install this on your system, as an instance of Maven will come bundled with your skeleton Spring Boot project, but more on that later. To run the PostgreSQL database we'll be using later, you'll need Docker installed on your machine. To check that you have Docker installed, open up a terminal or a command prompt and type docker --version. You should get a version number printed out, otherwise head over to docker.com to download Docker. To run the front-end code, which I'll provide, you'll need Node version 20 or later. You can check the Node version by opening up a terminal or a command prompt and typing node--version. Again, note that it's two hyphens in front of version for Node, just like Docker, but unlike Java, which only uses a single hyphen. So again, you should get a version printed out. Now, if you don't have version 20 or later, then I'd recommend heading over to nodejs.org to download a later version of Node. Now, for my IDE, I'm going to be using the community version of IntelliJ IDEA. You can use any IDE that you like, such as Visual Studio Code. However, I recommend IntelliJ as it's brilliant for Java development. You can download the community version of IntelliJ for free from the JetBrains website. So with everything installed, let's check out the requirements of what we're going to be building. Let's review the requirements of the blog application that we are to build. The project brief itself can be found on the Devtiro community site. If you don't have access yet, then I'll leave a link in the description where you can get access. If you can't join for whatever reason, no problem. I'll be showing you all the requirements right here anyway. So once you're logged into the community site, if you scroll down here and then go to project briefs, you come to this page here. And if we scroll down a little bit, we can see the blog platform. So let's click on this and let's expand this. So the project brief itself is broken down into a few different sections. So we have a summary at the top, some definitions next, and then some user stories and some acceptance criteria. So let's go through this from the top. So the summary is just a high-level overview of the application that we are to build and the problem that it solves. In this case, we can see the blog platform is designed to provide users with a space to share their thoughts, experience, and expertise through written content. And the platform will offer an intuitive interface for creating, managing, and publishing blog posts. So all of the things that you would expect from a typical blog application. If we scroll down a little further here to the definitions, let's go through these. So to start with, we have the definition of a post. A blog post is a piece of written content that includes a title, body text, optional images, tags, and publication date. And then we learn that posts can be drafts or published articles. Images aside, because we won't be dealing with images in this build, this is a great piece of information for what goes into a post. Title, some body text, tags, publication date, and then we have a status here of draft or published. So let's move on to category next. So we can see a category is a broad classification used to organize blog posts into main themes or topics. And we can see some examples: technology, travel, personal development. So the relationship between the two is that a post belongs to a category. It must have a category. So when you create a post, if the topic is on technology, then you would select the technology category, travel category, personal development, so on. And of course, you can create categories as you like as well, but we'll get to that in a moment. So broad classification, that's our category. So let's move on to a tag next. And this is a specific keyword or phrase that describes the content of a post in more detail than categories. So a tag is similar to a category, but we can see here, unlike categories which are broad groupings, tags are more granular and flexible. And a key piece of information here: a single post can have multiple tags, whereas a post can have only one category. A key difference between a tag and a category there. So now that we've got our definitions, let's move on to our user stories. If you're unfamiliar with this pattern, a user story describes what a user wants to do from the point of view of that user. This little nuance is enough to give us some additional context over the system must do X or the system should do Y. And of course, more context helps us to make better decisions during development. So let's take a look at this first user story here, content creation. As a writer, I want to create and edit blog post with a rich text editor so that I can express my ideas effectively with proper formatting. So we can see here the user in this case is a writer, wants to create blog posts with a rich text editor. Now, following the user story, we have some acceptance criteria, and these are statements which can be either true or false. And the idea is, once all of the acceptance criteria evaluate to true, then this user story is complete. So let's go through these. Users can create new blog posts using a rich text editor. Currently false because we haven't built our application yet, but once our application is built, we can make this statement true. We want the editor to support formatting options such as bold, italics, headings, and lists. Posts must have a title and content body. This is important to give us an idea as to the structure of a post. Users can edit existing posts with all changes being saved, and users can delete posts with a confirmation prompt. And finally, posts should display an estimated reading time. So we can see here we have 6 acceptance criteria in addition to the user story, and they're all based around the concept of posts, creating posts, editing posts, managing posts, etc. So let's move on to our next user story. And this one is around content organization. So as a content creator, that's our user this time, I want to categorize and tag my posts so that readers can easily find related content on specific topics. So this user story is all about categories and tags. So the acceptance criteria here, users can assign one category to each post. Users can add multiple tags to each post. Users can create and delete categories. Users can create and delete tags. And the platform displays category and tag counts. So that's to say how many posts have that tag or are within that category. So that's content organization, so categories and tags. Let's move down to draft management. As a blogger, I want to save drafts of my posts so that I can work on content gradually and publish when ready. And we can see the acceptance criteria. Posts can be saved as drafts. Users can preview drafts before publishing, and draft posts show the last modified date because you want to know the last time that you updated them. So we can see this is all around the idea of having draft posts before you publish them. And then we have some bonus features. However, we're not going to be implementing any of the bonus features in this build. We are going to be focusing on the core requirements here. So with the requirements covered, let's now move on to modeling our domain. A fundamental step in any object-oriented programming project is to define the objects or domain that we'll be working with. The project brief has all of the information that we'll need in order to model our domain. So we're going to look at it again, but this time through the lens of domain modeling. We're then going to take what we learn and we're going to represent the domain we are to build in several diagrams. So let's start by looking at the project brief once more. So at this point in the domain modeling process, we're looking for nouns. We're looking for the things, the objects that we are to build. And it's pretty obvious what we have. Post, great example of an object. That's a noun, and our blog platform is going to be dealing with posts. We also know that a post belongs to a category. Category being another noun, a great example of an object. Also, tag. A post can have many tags. Therefore, a tag is a great example of a noun, an object that we can use in our domain. If we look for this line up here, post can be drafts or publish articles. This gives us an idea of a state a post can be in, either a draft state or a published state. And considering a post can only be in one of those two states, that's a great example of an enumeration or an enum that we can use in our domain. In addition to that, we have this concept of a draft post, which is restricted to only certain people. Only certain people can view these draft posts, such as the person writing the post. Everyone else, the public, they're not to see these draft posts until they are published. Therefore, this tells us that we'll need to model the user. We'll need to have some authentication where a user logs in order to see drafts, but everyone who's not logged in, the general public, they won't see the drafts, but they will see the published articles. So user, that is another object that we'll need inside of our domain. In addition, there's plenty of information about our particular objects. So we know that a post has a title, some body text, tags, publication date. A category, well, that's almost certainly got some form of name, technology, travel, personal development. Same for a tag, Python, machine learning, book review, etc. Let's just do a high-level overview of some of these stories. Estimated reading time. Again, that could be another member of one of our domain objects. Category and tag counts. Again, that could be another member there. Draft management. We've already talked about the draft versus published status. And then we go on to our bonus features. So having looked through our project brief, I think we have enough information now to start designing our domain. So here we have a domain model. I've extracted the information from the brief and I've composed it in this domain model here. And it's there to show the objects that we're dealing with and the relationships between them. And we can also see some members of these objects. So if we just start in the middle here with post, we can see that a post has a title and it has some content. We saw that earlier. A reading time. And then we'll want to know the time and date the post was created and then last updated. Of course, a post needs some way of identifying it, so we have this ID here. And then we know a post belongs to a category. And I've given here category an ID, some way of identifying it, and then a name. The tag is modeled very similarly, so a post can have multiple tags. A tag at this point has an ID and a name. And then we have this post status. So a post can have a status, and the two statuses that we've identified are either draft or published. When a post is in draft, only certain people can see it, but when a post is published, it's available to the general public. And then, of course, we have this user up here. So the user that writes posts, or put another way, the post's author. So this user needs a unique identifier, which I've represented up here with ID. They also need some information that they can use to authenticate with our system. An email and a password is a fairly standard approach, so I've included those as well. This user I've determined also needs a name, and then we'll also store the date and time that user was created. I don't think it's necessarily important to store the updated date time right now, but it would be useful to know when that user was created. We can always add to that in future, of course. So this is our domain model. So having thought on this a little further, I then built it out into a class diagram. And that represents the classes that we are to implement in our system. And that looks like this. You have to forgive me that it's a little non-standard. I had to get a bit creative to fit it all on the slide, but here we are. So you can see it's very similar to the domain model diagram that we were just looking at. But of course, this has some additional information on there. We can see the types of the instance variables. Here, an ID I've decided should be a UUID, an email a string, password a string, so on and so forth. And I've also looked to elaborate on the relationship between our objects here. So a post can only have one user, represented by the number 1 here. But a user can write as many posts as they like, represented by this asterisk. A post can have one category, but a category can be linked to many posts. A post can have many tags, and a tag can belong to many posts. And then we know, of course, that a post has a status. It will either be draft or published. And you can see here that we've also represented those relationships as members, as instance variables, as we'll implement them. So we can see here post status is the type, and we've called that one status. We can see a set of tags here, and that is our relationship to tag. User author, that's our relationship back to the user here, the author of the post. And then we've got all of the other members that we're already familiar with. Title, content, created, updated, so on and so forth. So having analysed the project brief, I believe these classes would be a great place for us to start when implementing our project. But before we get to that point, let's now take a look at the user interface and see how it relates to this domain. Let's now take a look at the user interface for the blog platform that we are to build. So here's the current iteration of the blog platform. There are a myriad of different ways that this can be improved. However, it does meet the requirements and it will help us to develop our Spring Boot backend. So let's take a look through it. So on the home page here, we can see it's titled blog posts, and this contains our blog posts. Top one here, spaghetti, a love letter. We have one about woodpeckers and why boats are cool. So all dummy data, but it does show us a few things. We can see here the title of a post. We can see here the user that wrote the post. We can also see a snippet from the post. So we can see here we've got a date, and that's the date that the post was created. And then we've got a 2-minute read time, so how long the post will take to read. And then we have 2 little chips here. We've got one lifestyle and then the other one food. And we can see food has a little tag next to it. So this is how we represent the category, which in this case is lifestyle, and the tag, which in this case is food. But this post can have any number of different tags associated with it. If we scroll down to the next one, we can see again date, read time, travel tips, and very similar for the third post here. Now, if we take a look at the top here, we can see that we've got technology, travel, lifestyle, fish. These are our categories. By clicking on a category, we can see that we only see the blog post in that category. Again, very similar for the tags. If we only wanted to see posts with the food tag, if we clicked on that here, we can see spaghetti, a love letter, the one post with the food tag. Now, they can be used in combination. So we could say select lifestyle, and we can see here lifestyle food, lifestyle travel tips. If we then selected the tag travel tips, we only see one blog post. However, they're not fully fledged facets. The count doesn't update, but you could consider that a bonus feature if you did want to implement it. So let's now take a look at the blog page. So we can see here, we can either go back to the post page, otherwise we have the content of the blog post here. We can see the category, we can see the tag. So that's our blog post page. Let's now take a look at a blog post where we can see some formatting. So we can see here that we have some bullet points on this one. And we can see here we've got a title, so a H2 on this one. Now let's take a look at the categories and the tags pages. So we can see here we have the category lifestyle with a post count of 2, the category travel with a post count of 1. If we go to the tags page here, it's very similar. Travel tips, post count of 2, food, post count of 1. Now these views do change once you log in. So let's log in here. And then the password. And let's click on sign in. So now that we're signed in, we can take a look at the drafts and we can see we have a single draft post here, the same screen. However, because we're logged in, we can then edit. We can see we can change the title here. Maybe we want to make something bold, italics. Then if we scroll down, we can edit the metadata such as the category it belongs to. We can add some new tags. We can change its status from draft to published. And then if we click on update post, we can see that draft posts no longer contains any posts. However, we do have a new post here. It's all about coding. Then of course, if we wanted to add a new post, we can do so here. The screen is very similar. Of course, all of the fields are empty to begin with. And then if we chose to, we could also delete a post. Are you sure you want to delete this post? Yes, we are. And then the post is deleted. In addition to this, we're also able to delete the categories. So let's say we didn't want the category of fish any longer. We can delete that. And the same over on tags. We can delete, say, pasta here. Now you'll notice the delete button for travel tips and food. Well, that's grayed out, that's disabled because we can't delete a tag that has posts associated with it. And the same is true for categories. So you can see we can't delete travel or lifestyle. They are grayed out because they have a post count greater than 0. And of course, we can log out here and all of the extra functionality goes away. Now, it should be noted that we've implemented very, very basic authentication, but not authorization. So what that means is the user that logs in is able to see all of the drafts and they're able to update all of the posts. We haven't implemented authorization. That may look like a user only being able to edit their own posts. Authorization is outside of the scope of this build, but you can consider that a bonus feature if you did want to go ahead and implement that. So now that we're familiar with our user interface, let's now look at the architecture that we are to implement. So let's take a look at the architecture of the solution that we are to implement. The architecture for the solution is very straightforward. A user will interact with the React front-end application, and we saw that in the last lesson. The React front-end application will interact with the Spring Boot back-end application via a REST API. So that's to say the front-end will make calls to the back-end, and then the back-end will respond with the information that the front-end needs. The Spring Boot back-end application will save all of its information in a relational database, which we're going to use PostgreSQL. And we're going to run PostgreSQL in Docker to make things easy. Our Spring Boot backend is going to interact with the database using Spring Data JPA. So put another way, we're going to interact with the database with Java objects. We're not going to be writing SQL directly. And that's all the architecture that we're going to need. So next, let's take a look at the REST API that we are to build. Let's now take a look at the design of the REST API that we are to implement. Now, it's worth noting that this is the REST API that our front end expects. So we'll need to implement it as it's seen here. However, there's nothing to stop you from implementing a different REST API design. However, you will need to provide your own front end for that build. So let's take a look at the REST API that our front end expects. So we can see here that the endpoints have a HTTP verb in this column here. And then we have the path. And then we have a description of what this endpoint does. And you can see that they are grouped up here. So we have one at the top, a second group, a third group, a fourth group. This first one here is about authentication. The next one is about managing posts, then categories, and then tags. So this first endpoint here is a post to API v1 auth login. Now on this particular build, we're using the prefix of /API/v1. This is optional and you don't need to use this prefix. However, a lot of production systems do, because it gives you the ability to introduce a v2, a v3, a v4, and in that way you can run multiple versions of a REST API side by side. So API v1 auth login. So to this endpoint, our user will post the email address and password, and if it's valid, they will receive a JWT. That JWT will then be provided on all calls that the front end makes to the back end. That's how the user will authenticate. So that first endpoint is authentication. Next, we have the post management endpoints. So we have get posts, and that will get all of the published posts. We have posts, and that will create a new post. And then we have posts specifying the ID, that will get a specific post. Put, specifying the ID, that will update the existing post. Delete, specifying the ID, that will delete the post. And then we have this endpoint here, which is post drafts, and that will get a list of draft posts. And that's only available for authenticated users. So basic create, read, update, delete behavior for our posts. Perhaps the only nuance here is our list by default will return all the published posts, and this endpoint here specifying drafts, that's only available for authenticated users, and that will return a list of draft posts. So next we have the endpoints for managing categories, get all the categories, create a category and delete a category. And it's almost identical down here, but for tags. Get all of the tags, create the tags, and delete the tag, specifying its ID. So now that we're familiar with the REST API design, let's look to create ourselves a new Spring Boot project. In this lesson, we'll create a new Spring Boot project by using the Spring Initializer. The Spring Initializer provides a web-based tool for generating Spring Boot projects with the necessary dependencies and configuration. To get started, navigate to start.spring.io in your web browser, and you should see a website that looks a bit like this. So now to select some configuration. We're going to select Maven as our build tool, so let's make sure that's selected there. And we're going to use Java as our programming language, so we'll select that also. For the Spring Boot version, we're going to choose 3.4.0, that being the latest general release version at the time of filming. By the time you see this, there may be a different version of Spring Boot available, so I'd recommend just going for the latest general release version. You can tell a general release version because it doesn't have the word snapshot after it, it won't have an M, it won't have an RC, it will just be a set of numbers, and you're looking for the highest numbers. So let's scroll down to our project metadata now. For the group, I'm going to choose Devtiro, and this just identifies the project. You could use a different group, it's not going to matter too much. For the artifact name, I'm just going to call this one blog, because we're creating a blog application. The name blog, that works too. For the description, I'll just say a blog application. The package name, Devtiro blog, works perfectly. And for packaging, I'm going to select jar, because that will bundle everything that we need into the jar file and make it easier to run. And I'm going to select Java version 21 as the latest long-term support release at the time of filming. Now if we scroll up here, we can select some dependencies. So let's click on the Add Dependencies button here. Now the first dependency we're going to need is Spring Web. We're going to be building a REST API, so let's use Spring Web to do that. We're also going to be interacting with the database using Java objects, so we're going to need JPA, so Spring Data JPA is our next dependency. We're going to be using a PostgreSQL database, so we're going to select the PostgreSQL driver as well. You can see that down there. To make development quicker, we're going to select Project Lombok, so we'll select that one too. I'll add it to the bottom of the list. We're going to be implementing some annotation-driven validation, so we're going to need the validation library as well. Again, that's put onto the bottom of the list there. And we're going to need the H2 database. We're going to be using PostgreSQL when we run our application properly, but we want the H2 database for our tests. So let's add that too, and that goes to the bottom of the list. Now, it should be mentioned that we are going to want some other dependencies a little bit later on. We're going to need Spring Security for one, because we're going to want to secure our application using JWTs. But rather than use the Spring Initializer for that, we'll simply add that dependency when we need it. With all of our configurations selected, let's now download this project and open it up in our IDE. In our previous lesson, we generated our blog application using the Spring Initializer. Now we'll understand the project structure and understand how the different components fit together. So let's head over to our IDE. So here we are in our IDE. This is the project freshly downloaded from the Spring Initializer. So let's start expanding some directories here. So if you're not familiar with this project structure, this is a typical Maven project structure. Source main Java containing our Java code. We can see here we've got the package that we declared in the Spring Initializer. In my case, Devtiro blog. And inside that package, we have the blog application class. We can see this class has a main method, so this is the entry point of our application. Further to that, we can see the @Spring Boot application annotation on top, marking this as a Spring Boot application. Other than that, we have our source main resources, and in there we have application.properties. This is where we'll place our properties to configure our application. At the moment, it only contains the application's name, which is blog. And then we have source test Java here. Exactly the same package, Devtiro blog, but we have a single test class, blog application tests. We can see this contains a single test here, just checking that the Spring context loads. And we can see that makes sense because on the top of this class, we have the @Spring Boot test annotation. And this will start up a test version of our application, so the Spring context is available inside of our tests. While we're here, let's just run this and see if it passes. Great, so the test passes absolutely fine. So let's minimize that. Now, if we scroll down to the root of the project, we have some files here. The ones I'll draw your attention to initially is mvmw and mvmw.cmd. These two scripts, combined with the .mvm directory up here, give us our bundled Maven instance. So we don't have to install Maven, we can simply use this instance that's bundled inside of our project. On Windows, we would call it using the mvmw command, and on macOS and Linux systems, we can use the mvmw shell script here. Of course, there's always the option if you're using IntelliJ that you can use the Maven integration, just like here. But let's minimize that for the moment. So let's now open our pom.xml file. This is our Maven configuration file, which contains all of the dependencies that we've included in our project. But that's not all. There is a lot in this file, so let's just go through it at a high level now. So we can see at the start, we have this node, the parent node. And this declares the artifact ID of Spring Boot Starter parent and the version of 3.4.0. You'll notice that matches the version of Spring Boot that we selected in the Spring Initializer. Well, that's exactly what this node does. So if a new version of Spring Boot does come out, you can change the version in here. We can see our group ID, com.devtiro in my case, and the artifact ID of blog. The version is 001 snapshot. That's fine, we won't really be versioning this project. And then we can see the name of the project and the description. So everything so far we selected inside of the Spring Initializer. So let's scroll down a little further. We can see the Java version that we selected in the Spring Initializer, version 21. And then we see some dependencies. Spring Boot Starter Data JPA. So we selected Spring Data JPA in the Spring Initializer, so that's why this one's included. Spring Boot Starter Validation. We selected validation in the Spring Initializer, so that's why this one's included. We then have Spring Boot Starter Web included for the same reason. And then we have our H2 database. Now, while we're here, I'm going to change the scope from runtime to be test. We only plan to use the H2 database in our tests, so I'm just going to select that now to make sure it doesn't get involved in any of our production code. Next, we have PostgreSQL, Project Lombok, and our Spring Boot Starter test dependency. So that should be everything that we need for the moment in our project. So let's just load those Maven changes. So before we move on, let's just make sure that we're in a good state. So I'm going to go to the Maven integrations here. I'm going to go to Lifecycle. I'm going to clean and install this project. Let's click on play. Great, so that's a build success. Now, if you wanted to do that from the command line, you can simply use that Maven wrapper that we saw earlier. So this is a Windows machine. So I'm going to go mvmw, clean, install. There we go, that's a build success. The command will be ever so slightly different on a macOS and Linux machine, and you can find that command in the lesson notes. So now that we know our project's in a known good state, let's move on to running our database. In our previous lesson, we explored the structure of our Spring Boot blog application. Now we'll set up the PostgreSQL database using Docker Compose, which will serve as the persistent data store for our blog. So here we are back in our IDE, and what we'll need to do is, if we just minimize everything here, and in the root of our project, I'm going to create a new file, and I'm going to call this one docker-compose.wml for YAML. Now this is the configuration file that's going to be used by Docker Compose. If you're unfamiliar with Docker Compose, it's a tool that defines and manages multi-container Docker environments. For our blog application, we'll need a PostgreSQL database server, and I'm going to include in there as well a database management interface. And we can do all of that via the YAML file here. So the content that we'll need will look like this, and I'll include this in the lesson notes. So we have two services running. We have DB, which is our PostgreSQL database here. We can see the Docker image Postgres latest. We're mapping ports 5432. So that means that the Postgres database will be available on our local host port 5432. If there's any issues, then we want our Docker container to restart. And we can see here a single environment variable, Postgres_password. This is how we specify the password for the Postgres user to our Docker container. In this case, we're using the password change_me_in_prod ! Of course, it goes without saying, but you shouldn't use this approach in production. You should keep your secret secret. But as this is a development environment, we're just going to specify that password in there now. The second service that we're running here is Adminer, running the latest version of Adminer, again, always restarting, and we're going to make it available on port 8888. And it's via this interface that we can take a look at the database visually. Again, it's completely optional, but it is there if you do want to use it. You would log into Adminer using the same credentials as our application. So now that we have our Docker Compose file, let's open up a command prompt or a terminal, and let's run the following command. Docker-compose space up. Now you can see here I get an error. Now I do have Docker installed, but Docker currently isn't running. So if you do get an error that looks like this, the simple fix is just to start Docker on your machine, which I'm going to do right now. There we go, so that's Docker started up now. So I'm just going to run that same command once more. There we go, and we can see our Docker container has started up. So here's DB1, so Postgres, and we can see it's listening on port 5432. The database system is ready to accept connections. That's exactly what we want to see. If we scroll up a bit further here, we should see some console outs from Adminer. Yes, development server has started. So it looks like our environment is up and running. In our previous lesson, we set up a PostgreSQL database using Docker Compose. Now let's configure our Spring Boot application to connect to this database. So Spring Boot uses the application.properties file to manage database connection settings, and we can find that in source, main, resources, application.properties. And let's expand this. Now, in order to configure our application to connect to the database, we'll need some properties that look a bit like this. I'll include these in the lesson notes. So let's go through these properties now. So we have Spring data source URL. We can see that we're specifying the connection string for the database. So it's a JDBC URL. It's a PostgreSQL database that we're using, running on localhost, port 5432, and the database that we want to connect to is called Postgres, which is a database that's typically available by default on any running Postgres instance. We then specify the username and the password that we're going to use to connect to that database. The username is Postgres, and the password is exactly the same as the password that we specified in our docker-compose.yaml. This one right here. So next we have some JPA configuration. Here we're specifying DDL-auto as update. So once we start creating entities, Spring Data JPA will then automatically start creating everything that we need in the database, all of the tables, sequences, etc. We're setting show SQL to true, so we can see that printed out, and format SQL is a part of that. And here we're specifying the Hibernate dialect, which is PostgreSQL. When we include a PostgreSQL driver in our pom.xml file, Spring Boot usually works this out, but it doesn't hurt to be explicit. So with our properties specified, let's try starting up our application and connecting to the database. So let's open up our project here, go to Java, Devtiro blog, the blog application, and then let's click on the green triangle next to the main class. And we're going to run blog application.main. Okay, so we can see the application started up successfully. And if we scroll up here, we can see all of the information about our application connecting to the database. Add a connection to PostgreSQL, PG connection. Great, so it looks like our application is started up fine and it's connected to the database. In our previous lessons, we set up the database infrastructure for our blog platform. We'll now integrate Mapstruct, a code generator that simplifies the conversion between our domain entities and our DDOs. This mapping layer is crucial for maintaining a clean separation between our persistence and presentation layers while reducing some boilerplate code. We'll only be configuring Mapstruct in this lesson, we won't be using it. So we'll explore all of the details of using Mapstruct a little bit later in the course. So here we are back in our IDE. Let's take a look at our pom.xml file. Now you remember from earlier that we selected Lombok. We're going to be using that in order to create domain classes a lot faster than we would have without it. By using Lombok annotations, it's going to generate code for us. Now, we're also going to want to use Mapstruct to generate code. So to make sure that they work nicely together, we need to set up our project in a very particular way. And that starts up here in our properties. So in our properties, we're already specifying Java version 21. I'm going to add 2 more entries to that properties node. Here we're specifying the Mapstruct version of 163 and the Lombok version of 1.18.36. We're going to specify the Mapstruct dependencies in a moment, so it makes sense while we're including the Mapstruct version. But you might be wondering why we're specifying the Lombok version here, because Lombok was working perfectly fine without this. And the reason I'm including the Lombok version is that I'm making sure that the version of Mapstruct is compatible with that particular version of Lombok. So let's now use our properties. So if we scroll down here, we've got Lombok. So I'm just going to specify a version node on there. Using the $and braces annotation, I'm going to specify lombok.version. So that's going to use the version that we specified in the properties. And the next dependency we have is a test dependency. So I'm just going to create a new line and place in our Mapstruct dependency just before the test one, so everything is nice and organized. So we can see here org Mapstruct. Mapstruct is the artifact ID, and we're using the version that we specified in our properties. But it's not enough to specify the dependency. We're also going to have to configure the Maven compiler plugin. So let's scroll down a bit further, and we can see here the Maven compiler plugin. Now we can already see in here the annotation processor path for Lombok. I'm going to replace that with a more elaborate configuration here. So let's just expand this and go through it. So we're specifying the Lombok annotation process path just like before, specifying the version from up in the properties. We're also including Mapstruct in this configuration as well. We can see the Mapstruct processor, again using the same version that we specified in properties. And then we have a third entry, which is our Lombok Mapstruct bindings. And that version is 0.2.0. And these dependencies in this particular order will allow Mapstruct and Lombok to work together, at least in my experience of building this project. So let's just refresh Maven here, load our Maven changes. So that's all loaded. Let's open up Maven and let's again run clean and install. Great, that is a build success. It looks like our project is built fine and we're ready to use Lombok and Mapstruct. To run the front end, you'll need the front end code, and you can grab this from the Devtiro community site. There'll be details in the lesson notes. Once you have the code locally, you need to open up a terminal or a command prompt and navigate to the directory containing the front end code. That's exactly where I am at the moment. Once you're here, you need to install the necessary dependencies, and you can do that with the following command: npm install. There we go, so that's all the dependencies installed. All that's left for us to do now is to run our application, and we can do that with npm run dev. Great, so that's our application running, and it will be available on localhost port 5173. So here we are on localhost port 5173, and we have our front-end application. As we progress through the project and start to build out our backend, we should see the front end starting to look like what was presented earlier in the course. In our previous lessons, we've set up the foundational infrastructure for our blog application. Now we'll create the user entity, which will represent user accounts in our system. So here we are back in our IDE. So let's open up source here, main, Java, and then in Devtiro blog, I'm going to create a new package, and I'm going to call this one domain. And inside of the domain package here, I'm going to create a new sub-package and call this one entities. We'll also be creating our DTOs in our domain package. So we're going to use this sub-package in order to organize them. So inside of domain entities, I'm going to create a new Java class, and I'm going to call this one user. And let's expand this. Now, as we're creating a JPA entity, the first thing that I'll need to add to this is the entity annotation. And it would also be nice to specify the name of the table this is going to use in the database. So I'm going to use the @table annotation as well, specifying the name of users. I want this to use the table users in the database. In practice, this means that Hibernate is going to generate a table called users in the database, which this entity will map to. We're also using Lombok in this application. So let's add some annotations from Lombok. So we want a no argument constructor. That's something that JPA traditionally needs. We're also going to want an all arguments constructor, and we'll want getters generated for us, And we'll want some setters generated for us as well. And it's nice to use the builder pattern, so let's do builder2. Now you might wonder why I'm not using @data, and that has to do with our particular domain setup. Specifically, it's to do with the equals and the hash code that data generates when we use Mapstruct. So instead, we're going to have to use the getter and setter annotations separately. So let's start declaring some instance variables inside of our user entity, starting with our ID. So that's going to be a private UUID, and we'll call this one ID. Now the ID of a JPA entity needs to be annotated with the @ID annotation. And it would also be nice for the UUIDs to be generated for us. So I'm going to use the generated value with the strategy of generation type UUID. And that means if we try and save a user where the ID is null, JPA is going to generate a UUID for us and use that as the value. So that's the ID instance variable. So we know that a user is going to have an email. It's going to use an email and a password in order to log in. So let's specify that here with private string email. And on the top of this instance variable, I'm going to use the column annotation to specify some constraints. Nullable, false. We always want an email to be provided. Unique, true. We only want a single instance of each email in the database. We could also specify the name of the column in this annotation as well, but it would default to be the word email, and I'm pretty happy with that. It would default to be email because that's the name of our instance variable. The same for ID. Even though we've omitted the column annotation, inside of our users table in the database, this will be the ID column, this will be the email column. So a user is going to need to log in with a password. So we're going to say private string password. We'll put a column annotation on the top of this one, and we'll say nullable equals false. We always need a user to exist with a password. Next, we want the user's name, private string name. Again, we'll put a column annotation on the top here and add the constraint of nullable equals false. We always want a user to have a name. And the last thing on our user entity was the created date time. So we'll say private local date time. We'll call this one created at. And then we're going to put the column annotation on the top there and say nullable equals false. So with this, we have all of our instance variables specified, and we have the getters and setters generated for us with the annotations up here. We also have an all arguments constructor and a no arguments constructor as well. What we don't have is the equals and the hash code. And that's something that we need to generate. We need to write this one manually in order for Lombok and Mapstruct to work well together. This might not always be the case, but it certainly has been the case when I've been building this project. So if we right click here, we'll go to generate, and then we'll say equals and hash code. ID, email, password, name, and created at. Make sure they're all selected, and then we'll click on next and create. So that's our equals and our hash code implemented. So that will work for our JPA entity with both Lombok and Mapstruct in the mix. And now as a little bonus here, I'm going to specify a protected method, a void method, and I'm going to call this one on create. And I'm going to place the annotation on the top of this one, pre-persist. And this will say this dot created at equals local datetime dot now. And what this will do is every time a user entity is saved, where the created at instance variable is null, then rather than throw an exception, the local datetime.now, that value will populate the created at instance variable. And this will all happen pre-persist. So before the user entity is saved into the database. This is completely optional, but does make things a little bit more streamlined. And with that, we have completed our user entity. In the last lesson, we created the user entity. Now we'll implement the category entity, which will provide a way to organize blog posts into broad groups. This categorization system will help readers find content they're interested in and enable better content organization for blog authors. So here we are back in our IDE. So let's open up source main Java, go to domain entities, and we'll create a new Java class. And this one we'll call category. And let's expand this. Again, as an entity, we'll need to put the entity annotation on the top of this class. And then just like before, we're going to say table, and the name is going to be categories. So the plural of category. And then we'll specify a no R's constructor, an all R's constructor, getter annotation, a setter annotation, and the builder annotation, all from Lombok. And now we can start declaring our instance variables. We're going to go with private UUID, ID. And just like before, we're going to say at ID, and we'll use the generated value annotation, specifying the strategy of generation type UUID. Now a category also has a name. So we'll say private string name, and we'll say column annotation on the top there, nullable equals false, and unique equals true. We don't want multiple categories with the same name, and this constraint will help prevent it. And that's the only things our category is going to need for the moment. So just like before, we're going to have to manually generate the equals and the hash code. So let's right click, go to generate, equals and hash code, next, making sure ID and name is selected, create, and there's our equals and hash code. And that's our initial implementation of category completed. In our previous lessons, we created the user and category entities to handle user management and content organization. Now we'll implement the tag entity, which provides a more flexible way to classify and organize blog posts. So here we are back in our IDE, and inside of domain entities, we're going to create a new Java class, and we're going to call this one tag. Let's expand this. So the tag is going to be almost identical to the category, at least for the initial implementation. So let's add the entity and the table annotations. We'll specify the name of the table to map to be tags. And then we'll specify the all arguments constructor, no arguments constructor, getter, setter, and we'll have the builder annotation as well. Just like before, we'll specify a private UUID, and we'll call that one ID, adding the annotations of at ID and the generated value with the strategy of UUID. So a tag has an ID and it also has a name. So we'll say private string name and add the column annotation to this. Nullable, false. We always want a name. Unique, true. We want our tag names to be unique. We don't want multiple tags with the same name in our database, and that will help prevent it. And just like with our previous entities, we're going to generate our equals and our hash code. Next, ID and name selected, and then we'll create. And that completes our initial implementation of our tag entity. So far, we've created entities for users, categories, and tags. Now let's implement the post entity and its associated post status enum, which together represent the actual blog content in our system. These classes will enable us to manage blog posts throughout their lifecycle from draft to publication. So let's create the post status enum. So inside of com Devtiro blog domain, I'm going to put this one in domain rather than entities because I'm going to use this enum throughout the application. If I right click and then go new, Java class, and we'll call this one post status. And this will be an enum. Okay, so it's ended up in the entities package. So let's refactor and move this. And we'll move it to com Devtiro blog domain refactor. Okay, so now it's in the right place. And to implement our post status enum, we're going to specify the two states that a post can be in, draft and published. And with that, we've completed our post status enum. So let's move on to the post entity. So inside of the entities package, I'm going to create a new Java class and call this one post. And let's expand this. So just like we've been doing so far, we'll put the entity annotation and we'll specify the table that this class maps to, which is going to be posts. And then we'll add our Lombok annotations, our no R's constructor, all R's constructor, getter, setter, and the builder. And now we can start specifying our instance variables. And we know the post has an ID, and this is a UUID. So we'll say private UUID ID. Again, adding the @ID annotation there. And we'll say generated value where the strategy is UUID. We also know that a blog has a title. So we'll say private string title. And then in the column annotation on the top here, we'll say nullable equals false. We always want a post to have a title. We're going to allow posts to have the same title, as that's not unheard of. Now for the content. So we'll say private string content. And now in the column annotation for this, nullable equals false. We always want a blog post to have some content. And now we'll say column definition of text. And this will allow our column to handle varying content lengths. So as the content grows, the database can accommodate for it. Next, we're going to specify our post status. So we'll use our post status enum, and we'll call that instance variable status. And then we'll specify our column annotation, put that on a new line, and we'll say nullable equals false. We always want a post to have a post status. And in addition to that, we're going to use the enumerated annotation there, specifying the enum type of string. Typically, an enum would be represented as a number in the database. However, strings tend to be human readable and have some other benefits too. So we're going to use the enum type of string for this. Next, we'll specify a private integer of reading time, because we're going to calculate the reading time in minutes before we save the post. And that would be less resource intensive than having to do it every single time we display the post. So in the column annotation on this one, we're going to say nullable equals false. We always want a post to have a reading time. Next, we have our local date time for created at. So the date and time that the post was created. We'll put a column annotation on the top saying that nullable equals false. And then we'll specify our updated at. So local date time, updated at. And again, we'll say that the column nullable equals false. Now, just like we've been doing so far, we're going to generate the equals and the hash code. So we'll go generate equals and hash code. Next, making sure everything is selected. Next, create. So there's our equals and our hash code. And now let's use our pre-persist annotation again. So we'll say pre-persist, protected method, void, and we'll call this one on create. So on create, we want to set the created at to be local datetime dot now. Put the equals in there. And let's assign this to a variable, because we're also going to set the updated datetime to be now also. So when a post is created, both the created and the updated date time will be exactly the same date time, which is the date and time right now. In addition to this, we're also going to use the pre-update annotation. Protected void on update. And for this, we're just going to set the updated at equals local datetime dot now. So whereas this method will only be called when the entity is created, this one will only be called when the entity is updated. For the create, it would update the created at and updated at, whereas for the update, it will only update the updated at instance variable. And with that, we have completed our initial implementation of our post class. In previous lessons, we've created our user and post entities. Now let's configure the JPA relationship between them. So here we are back in our IDE, and let's start with our post entity, expanding this. Let's scroll up to our instance variables. So a blog post must always have an author, and this relationship needs to be enforced at the database level. So let's update our post entity to include the author relationship. And we're going to do that by adding a new instance variable here. Private, user, and we'll call this one author, because the user represents the author of the post. Now we're going to add some annotations to the top of this instance variable. And the first one is going to be the many-to-one annotation. And we're going to say the fetch type is lazy. And we're also going to specify the join column annotation here. And the name of the join column is going to be author underscore ID. And we're going to say nullable equals false. So the fetch type lazy configuration optimizes performance by loading post authors only when they're explicitly accessed. The join column annotation specifies that it's the column named author ID that is going to reference the author's ID, so the ID of the user to which this post relates. But we're not done yet. So we've done the post side of the configuration. Let's now move over to the user side of the configuration because we're setting up a bidirectional relationship here. So let's go to user. Now, after name, I'm going to put a new instance variable in here. Private is going to be a list of post, and we'll call that one posts. And we're going to initialize that to be a new array list as well. And let's import list. We're initializing post to be a new array list because that helps prevent null pointer exceptions. And we're going to add an annotation to the post instance variable, and that's going to be one to many, which is the opposite to what we've put on the post. Note it's many to one here, and on user, it's going to be one to many. And inside of that annotation, we're going to specify mapped by to be author. And what that means is it's going to go to the post class and look for the author instance variable for the configuration that it needs. So let's now set up the cascades for this relationship. We're not going to specify any cascades on the post side since a post can't create or modify its author. So let's head over to the user class. Now inside of the one-to-many annotation here, we're going to specify the argument of cascade, and I'm going to specify cascade type all. And I'm also going to specify orphan removal, specifying that to be true. So what this combination means is when a user is deleted, all their posts will be automatically deleted. And this helps to maintain our database integrity. It would also be the case that if we added any new posts to our post collection here and then saved our user, those posts would also be saved. Although we may want to change this behavior later on, at this point in development, this sort of setup makes sense. So with that done, that's our initial setup of our user post relationship. So in our previous lesson, we set up the relationship between our users and their posts. In this lesson, we're going to set up the relationship between category and post. So each post must belong to exactly one category, and that establishes a mandatory one-to-many relationship, where a post always has one category and a category has many posts. So let's start over on the post class here, expanding this. So let's add a new instance variable, private, category, and we'll call this one category. And we'll add the annotation many to one on top. Again, fetch type of fetch type lazy. And we'll specify the join column with the name of category underscore ID. And we'll say nullable equals false. We always want a post to have a category. So a very similar setup between category and author there. So let's now go over to the category class. So let's add a new instance variable, private, and this is going to be our list of posts. And we'll call this one posts, and we'll say new array list. Again, helping to prevent that null pointer exception. And if we import list, and we'll put the one-to-many annotation on the top of posts, and we'll say mapped by category, because on the post class, it's the instance variable of category that contains all of the information about this relationship. A note on cascades here. No cascades are needed as categories and posts have independent life cycles. So deleting a category should be prevented if it has posts. And we'll handle that in our service layer. And posts don't create or modify their categories. So we're not going to specify any cascades for this relationship. And with that, we've set up the initial relationship between our category and our post. In our previous lessons, we've established relationships between posts and both users and categories. Now we'll implement a many-to-many relationship between posts and tags. And this will enable flexible content classification. This relationship will allow for each post to have multiple tags and each tag to be associated with multiple posts. So back in our IDE, let's start with the post class, and let's expand this. And underneath category, we're going to place a new instance variable, a private set of tags. And we'll call this one tags, initializing it to a new hash set. We're using a set here instead of a list as it prevents duplicates and improves performance. And we're not really concerned with the order that tags are returned in. So to the top of our tags instance variable, we're going to place the annotation many to many, declaring a many to many relationship. And now we need to specify the join table that's going to be used for that many to many relationship. And now we'll specify the arguments to this annotation. And the first one is the name of the join table. And we'll call it post_tags. And this is what Hibernate will generate for us. And now we're going to specify the name of the join columns. So we'll say join columns, and then we'll specify the annotation of join column, where the name is the post ID, and that's one half of the relationship. And the other half is specified with the inverse join columns argument here. And we'll specify the join column, where the name is tag ID. So in that join table, we'll store records where we map post IDs to tag IDs. And we've specified that here with this annotation. We've specified the post ID to identify the post and the tag ID to identify the tag. So that's the post side of the relationship configured. Let's now go over to the tag class. And we're going to add a new instance variable in here. And this will be a set of posts. Call that one posts, and we'll initialize it to be a new hash set. And to the top of this instance variable, we're going to place the annotation many to many. However, rather than specify all the information that we did before, we're just going to provide the mapped by argument, and we're going to specify tags. Because if we go to our post class and go to our tags instance variable, we can find all of the information about this relationship. A note on cascades. Tags and posts have independent life cycles. Deleting a post shouldn't delete its tags, and deleting a tag shouldn't delete its posts. This is why we're not going to specify cascade operations in our relationship mappings. So with that, we've set up the initial relationship between our tag and our post. And that wraps it up for part 1. Now, if you take a look over here, you should see part 2. And if not, it means it's not out yet. So be sure to subscribe and hit that bell icon to be notified when it does come out. And in the meantime, why not check this out?